So hi guys. In the last lesson, we performed an experiment to determine the average volume of tetraoxosulfate 6 acid required to neutralize a standard solution of sodium hydroxide. Now, after the experiment, we found out that an average of 15.63 milliliters of the acid neutralized 25 milliliters of the base. Note that the base is an aqueous solution containing 10 grams of sodium hydroxide in a 500 milliliter solution. With the values given in this lesson, we will find the following. We will start with the mass concentration of the base. Now, we've been given the volume of the acid used, the volume of the base used, and we've been told that the base is a solution of 10 grams of sodium hydroxide in 500 milliliters of solution. First of all, I want you to note that milliliters represent the same unit as centimeter cube. So 1 milliliter makes 1 centimeter cube. Now, the mass concentration of a substance is the mass of that substance in 1000 centimeter cube of solution. So, we've been told that the base is 10 grams of sodium hydroxide in 500 milliliters or 500 centimeter cube of solution. And we've been asked now to find the mass in 1000 centimeter cube, which is the mass concentration. So all we have to do is say how many X grams of sodium hydroxide will be in 1000 centimeter cube. When we find the mass of sodium hydroxide in 1000, that mass represents our mass concentration. Now, to do this, we simply cross multiply. This gives us that X times 500 will be equal to 10 times 1000. To find the value of X, we divide both sides by 500. When we do this, we have the value of X to be 0, 0 goes with 0, 0. 5 here, 1, 5 here, 2. So 2 times 10 gives us 20 grams per dm cube. What this means is that the mass concentration of the base is 20 grams per dm cube. Let's try another question. We've been asked to find the molar concentration of the base. Molar concentration of the base. To do this, we must remember a key formula given in our previous lesson. We said that the molar concentration, we can use that as molar conc, is equal to mass concentration over molar mass. So the molar concentration of the base, which in this case is sodium hydroxide, can be obtained by dividing the mass concentration, which we obtained in the previous question, by the molar mass of sodium hydroxide. Now, we have the mass concentration already, but we do not know the molar mass of sodium hydroxide. So we can solve for that using this. The molar mass of sodium hydroxide, we can obtain that by simply adding up the atomic masses of each of the individual elements. We know that sodium is 23, plus oxygen is 16, plus hydrogen 1. This gives us 40 grams per mole. So now we can solve for the molar concentration of sodium hydroxide, which is the base. To do that, we have molar concentration equals the mass concentration we obtained to be 20 grams per dm cube. So equals 20 grams per dm cubed divided by 40 grams per mole. When we divide this, we should obtain 0.5 mole per dm cube. So this is the molar concentration of the base. Let's try one last question to obtain the molar concentration of the acid. Now, we know nothing about the acid, but we can obtain the molar concentration of the acid using a formula we gave in the previous lesson. We said that the concentration of the acid times the volume of the acid over the concentration of the base times the volume of the base is equal to the number of moles of the acid divided by the number of moles of the base. Now, using this, we can obtain the value of Ca, which is the molar concentration of the acid. So since we're looking for Ca, we do not know what it is, we'll call it Ca. So we're trying to take down our parameters now. The volume of the acid we were given previously to be, let's check, we were given to be 15.63 milliliters. 15.63 milliliters. Next, the concentration of the base. Concentration of the base is 0.5 mole per dm cube. We solved for that earlier. So this is milliliters or cm cube. Remember, we said that they are the same thing. Next, the volume of the base. We were given the volume of the base to be, let's check. Volume of the base is 25 milliliters, which is also 25 centimeters cubed. So we have that, 25 centimeters cubed. Then, for the number of moles of the acid and base respectively, all we have to do is to write down the balanced equation of this reaction. The balanced equation will tell us the number of moles of the acid, H2SO4, that reacts with the base, sodium hydroxide. So, the balanced equation, H2SO4 plus sodium hydroxide, this should give us sodium tetraoxosulfate 6 plus water. So we have to balance this equation. We should put 2 here and 2 here. This balances the equation. So we can see that 1 mole of the acid H2SO4, so Na is 1, reacts with 2 moles of the base, so Nb is 2. Now, let's open another tab quickly and solve. So we do not know Ca, so we have Ca times Va, we have the value 15.63 over the value for Cb to be 0.5 times the volume for B to be 25, and this is equal to Na, which we know to be 1, over Nb, which we know to be 2. Now, the next thing for us to do is to cross multiply so that we can obtain Ca. When we cross multiply, we have Ca times 15.63 times 2 equals 0.5 times 25 times 1. Next thing, we multiply by the reciprocal of all that is attached to Ca. Basically, divide both sides by 15.63 times 2 divided by 15.63 times 2. This enables us to get the value of Ca. So Ca becomes equal to 0.5 times 25, let's do that with our calculator, times 1 divided by 15.63 times 2. Now this gives us 0.399, which is approximately 0.4 moles per dm cubed. So we have the molar concentration of the acid to be 0.4 mole per dm cubed. And that's all for this lesson. In another lesson, we'll try some more questions involving titrations. I'll see you then.